Hey guys, hope we're having a good weekend. If we look at the position, velocity, and acceleration portion of this, for this first one here, number 6, if we want to find the times at which something is at rest, well, that's when the velocity is equal to 0. So if we're given the position function, the velocity function can be found by taking the derivative of that. So we take the derivative of position and we get 6t minus 2. And we want to know when is this equal to 0. So when does 6t equal 2? When t is equal to 1/3. Okay, this question's kind of similar to the one that we just had. But now we want to know when it's moving to the right. So we want to know when is the velocity greater than 0. So v will be equal to 3t squared minus 8t plus 4. And when does this equal 0? Well, there's only one way to factor 3t squared, and that's into 3t and t. Okay, so now we need to make a positive 4 minus 2 minus 2. Yep. So we get t is equal to 2/3 and t is equal to 2. So let's set up a number line where this is our velocity number line. We have 2/3 and 2. And we know that the velocity is 0 at those places. We need to test any value of time that's not one of those two. A really nice value of time to test, because t is greater than or equal to 0, is let's test 0. If we plug in 0 into the velocity, we get 0 minus 0 plus 4. So positive. Since this was 3t minus 2 to the first and t minus 2 to the first, we're going to have sign changes at both of those. So it is moving to the right when t is between 0 and 2/3, and then again when t is greater than 2. Okay, so if we want to take the derivative here, we need to use the product rule, because we have e to the negative t times the sine of t. The derivative of the first, so the derivative of an exponential function, e to whatever is up there, times the derivative of whatever's up there. So we really have negative e to the negative t times the sine of t plus e to the negative t times the derivative of sine is cosine. When does this equal 0? If we factor out an e to the negative t, we have negative sine t plus cosine t is equal to 0. There's nothing that I can plug in for t that I can put in the exponent of a real number and have that be equal to 0. So this will never be equal to 0. From this part, when does, if I add over the sine of t, when does the cosine of an angle equal the sine of an angle? There are two places on the unit circle where the cosine and the sine equal each other. That is when t is equal to pi over 4 and 5 pi over 4. Write an expression for the acceleration. So if I want to write the expression for the acceleration, we need to take the derivative of velocity. Okay, so the derivative of the first, we have negative e to the negative t times the second minus sine of t plus cosine of t plus the first, e to the negative t, times the derivative of the second, sine, cosine minus cosine, minus cosine of t minus sine of t. And there's an expression for the acceleration. We're just taking the derivative of velocity. I mean, we could clean that up a bit, but it's really not worth it. Okay, so last question. Okay, so the first part says that as you read all of this, this has an area of 8, this has an area of 3, and this has an area of 2. And when is the particle furthest to the left? Well, at t equals 0, t equals 3, t equals 5, and t equals 6. At these times, we can say where the particle is, or what the position is. And so when t is equal to 0, the particle is at x equals negative 2. So x equals negative 2. When t is equal to 3, so if t is equal to 3, we have negative 2 minus this 8, because that's below the x-axis. So x is equal to negative 10. Remember that negative velocity means that we're moving to the left. And then when t is equal to 5, well, we were at negative 10, but now we've gone 3 units to the right, so x is equal to negative 7. And when x is equal to t is equal to 6, x will be equal to, well, now we're going 2 back to the left, so we're at negative 9. So find both the time and the position when the particle is furthest to the left. Okay, so the time is going to be at 3 and the position is going to be at 10. So at t equals 3, x is equal to negative 10, since at t equals 3, velocity changes from so our velocity at 3 changes from negative to positive. So that's where we have minimums, when the velocity changes from negative to positive. Okay, so for what value of time does the particle change direction? Well, the particle is going to change direction when the velocity changes signs. So at 3, we change from negative to positive, and at 5, we change from positive to negative. Nope. The particle changes direction. SIGN. Okay. On the interval, the speed of the particles increase. Okay, on the interval from 2 to 3, is the speed of the particle increasing or decreasing? So from 2 to 3, we want to show that the velocity and the acceleration have the same sign, or opposite signs. So we're checking the sign of velocity and acceleration. So C. So from 2 to 3. So from 2 to 3. V is definitely less than 0 because it's below that t-axis. But from 2 to 3, the velocity is increasing. So our acceleration is greater than 0. So yes, it's below the x-axis, but it's increasing. So the acceleration is greater than 0. The speed on the interval 2 is less than t is less than 3 of the particle is decreasing, since v is less than 0 but increasing, or the acceleration is greater than 0. So the velocity is less than 0, but it's becoming less negative, so it's the velocity would be increasing. And then during what time intervals, if any, is the acceleration of the particle negative? So the acceleration of the particle negative. And then on the last quiz, it was kind of like, when would the second derivative be negative, or when would it be concave down? So the acceleration is going to be negative when, let me just pick a color here, something orange like this. The acceleration is going to be negative when the velocity is decreasing. So from 0 to 1, and from 4 to 6, because we were told that we had horizontal tangents at 1 and 4. And then we'll justify that. Since the velocity is decreasing. Okay guys, I hope these help. I hope senior review went well, and I hope you guys had a great weekend. Let me know if you have any questions.